Hello everybody, this is John Finari from the Sociology Department at Queens College, and today we're going to be talking about using pivot tables in Google Sheets to create frequency distributions and cross-tabulations. So the first thing we have to do is open up Google Sheets, and we want to use a file that has data in it, and you should all have a sample data file. And the sample data file we're going to be using is a subset of the General Social Survey from 2006. This is a small piece of that larger data set. There are many variables and thousands of rows or cases in this data set, but we're going to use a small subset or a medium-sized subset of that data set. So first thing you need to do is save that data set, the GSS file, in Google Drive. And assuming you've done that and you have the file here in Google Drive, we're going to double click on that and it shall open the file in Google Sheets. So we're going to look at the three tabs on this file. We have the first tab is the actual data. The name of that tab is GSS06, and you can see the variables names across the headers of the columns: age, sex, rel person, relj atid, praying, prayer. And you may be thinking, well, what do these abbreviations stand for? Well, we know what age and sex stand for, but what are these variables? Well, that's what the second tab is for. The second tab of this file says variable info. And when you click on that, you will see that you have a list of variables, and they are numbered in the order that they appear on the file. And then they have the column, so you can see that the first variable is in column A, and that is age, and it gives you a long variable name. So essentially a little more information about what this variable is. So we could look at that third variable that had a weird name, RELPERSN, and that is, does respondent consider self a religious person? So that'll give you some more information about what those abbreviations stand for. I'm going to go back to the data here, and you can tell pretty quickly if the variables are qualitative or quantitative based on the information in the cells. For example, age is obviously quantitative because it is measuring a quantity. This very first person, first respondent, has an age of 20. Whereas sex is a qualitative variable because the category values are numbers. The cells contain values or characteristics of the variable or the attributes of the variable. So for sex, it is male or female. So that's another important thing as you're working through this exercise. We're going to be looking to identify qualitative and quantitative variables, and that's very often one of the things you'll do when using Google Sheets to do some type of data analysis. Okay, so now that we know what the data file looks like, and as you can see, there are quite a few variables here. If we scroll left to right, and quite a few cases if we scroll way down to the bottom. So there are 4,510 cases. You'll see there's 4,511 rows, but don't forget the top row is the header row. And if we go over here to the variable info, we can scroll down and we can see that there are a total of 72 variables in this subset. Alright, so I want to move on and look at this last tab. This last tab is a tab that I've created for students to help them with this exercise on creating pivot tables. We're going to need some information here. So I have listed three variables: the independent, the dependent, and the control. And I've given some information about the position that you need to put them in your pivot table when creating a pivot table. You'll notice that the name of the independent and dependent variable are blank, and I've highlighted them in yellow. This is something that each student has to fill in. So you're going to need to identify your independent variable and your dependent variable. I've already picked everybody's control variable. Everybody's control variable is going to be the variable sex. And then there's going to be some information that you'll need to help create those pivot tables. And I've given you that information here so that you'll have it at the ready when you're working on pivot tables. And that's the data range. That's the data that you want the pivot table to look at when it's doing what it does. And the insert to, this is where you want the pivot table to go in this Google Sheet. So I keep saying this word pivot table, and you're probably wondering, what is a pivot table? Well, pivot table is a really powerful tool that is included in Google Sheets, and it is used to summarize large data sets. And essentially what it does is it sorts and filters and calculates statistics all at the same time for multiple variables, as many variables as you want. So if I go back to this data set, you'll notice there are, I believe we said there are 72 variables, and there are 4,510 rows of data. What if I were to ask you how many males or females were on this data set? Well, that would be a tricky task just by scrolling through this file, right? Or if I wanted to know the average age, that would also be a tricky task. I mean, you get the sum of this column and divide by the total number of cases to get the average. But what if you wanted to break that down by gender? What if you wanted to know what's the average age for males or the average age for females? Or if you wanted to look at a variable like whether or not somebody has a gun in the home, yes or no, and whether or not they are what their political party is, or if they're liberal or conservative or moderate. You might be interested in, well, I wonder if people who are liberal or conservative or moderate are more or less likely to own a gun or to have a gun in their home. These are the types of data questions that people have. And when you look at this massive file, it's really hard to think about, how would I answer that question? Well, pivot tables are a really useful tool for answering those questions. So I'm going to go to this PT tab, and I'm going to create our first pivot table. And the first pivot table I'm going to create is, well, no, I can't do that. Before I do that, I have to make a decision. Sorry. We have to make a decision about what my independent and my dependent variable are going to be. So I'm going to I've picked two variables already. The first variable, my independent variable, is DEG, and that is degree. That is the level of degree, educational degree, that each respondent has completed. And that is, did they finish high school? Did they get an associate's, a bachelor's degree, master's degree, or doctorate degree? And the second variable is happy. That's my dependent variable. And happy is just a general measurement of how happy the respondent is. And there's three category values: not happy, happy, and very happy. So I want to know, does your college degree influence your general happiness? Right? So my independent variable is degree, my dependent variable is happiness, and my control variable will be sex. Now, if I were turning this into a hypothesis, I want to turn this into a testable statement of explanation, then my hypothesis would be that I think as happiness I think that as your educational degree level increases, you are more likely to be happy. So that's my hypothesis. It's a testable statement of explanation about the relationship between two variables, and I'm going to test that association here. So the way I'm going to do that is I want to know, of the people with different levels of educational degrees, how happy or unhappy are they? Well, I could go back here and I can sort through the file and look at the variable degree, which is, let's see if we can find degree. Degree is right here in column 0, and we can scroll over here, column O, You can scroll over here to column BH to find the variable happy. It would be really hard to determine if there's any pattern or relationship between people who are happy or not happy or very happy versus the categories of the variable degree just by looking at this data field. So we're going to create a pivot table. And the first pivot table we're going to create is a frequency distribution. Now, what is a frequency distribution? Frequency distribution is a really helpful tool for identifying the list of all the possible outcomes, or in this case, the attributes of the variable, and the frequency of occurrence in a data set. So we're going to make a table for, first thing we're going to do is frequency distribution for our independent variables. So let's take a look at what do we know about this variable degree in this data set. All right, so I'm going to click on this cell here, and this cell is cell A10. That's important to know, so remember that. What I'm going to do is I'm also going to copy this value here, this data range value, and you'll see why in a second. So I'm going to make a copy of the data of that value range, and I also want to remember where this pivot table is going to be. It's going to be in A10. So we're going to go over here to data and select pivot table, and it's going to ask us where do we want this pivot table. Well, I want this pivot table in the existing sheet. That is where I am right now, and I have to fill in two things: the data range, and that's the thing we just copied from over here, data range. We're just going to paste that in. Essentially what we're telling it is to look in this tab here where the data is, and I've given it the specific cells and the rows and the columns that that data lives in. And then the other thing we're going to do here is for where we want the pivot table, I want that to go right here in column A10, or to start in column A10. You'll see it'll take up multiple cells. And I'm going to use this language here. It's PT exclamation point, and then the column is A, and the row is 10. And hit create. And here is a pivot table. Now there's no information here because we have to tell it what variables to look at. But essentially it is going to look at this tab here, the tab with all the data, and it's going to summarize the variables that we select. So the first thing we're going to do, we're going to want to make a frequency distribution for the independent variable, which is degree. So I'm going to click over here to rows, and I'm going to select a variable. And it gives me a list of all the variables in that data set. I'm going to select degree, and you can see here now, these are the options. These are all the possible outcomes of variable degree. Associate degree, bachelor degree, graduate degree, high school or less. It doesn't put them quite in the right order, but that's not that important right now. The other thing we're going to do is we need to add some values because we want it to give us a count of each of those values in the data. So we're going to over here down to values, and we're going to select degree again. Now it's important to select, there's lots of different options. I believe the default is going to go to count or count A, depending on your computer and what you have set up, or if you've ever made a pivot table before. Double check and make sure that the value that it's giving you is count A. Count A will look for actual data in the field. It's kind of confusing because you would think count would be the right thing because you want it to count, but count actually counts something else. It counts some numeric values, and we're not dealing with numeric values right now. So we're going to make sure that we have degree as our value variable, and that it's summarizing by counting A. And take a look at what it's done for us. It's made a really nice table, and a really valuable table for us. It's not only given us a list of all the possible outcomes, but it is also giving us a count of how many times in that data set, right? We said there are 4,510 people, what the count is per category. so we can see how many people answered and what their answer was. Okay, so we're done with that's the simplest pivot table you can make. It's got one variable, one value, but it's a really useful tool. Could you imagine trying to scroll through this file and just count all of the instances of one of the degree values, high school or less, or look here for the associate degree? It would take a really long time to do that. Alright, so I'm going to do that again a little quicker the second time. I want to make a frequency distribution for the variable happy. That's our dependent variable. So I'm going to select down here. I'm going to skip a line. And now I'm in cell A18. Remember, we need that information. I'm going to go data and pivot table. And I'm going to paste in that data range from over here. And I'm going to tell it I wanted an existing sheet, and I have to tell it where to put the pivot table, PT exclamation point A18. Alright, so I've got my table, and now I'm going to select happy. That's pretty far down the list. I think there it is. So I put happy in the rows, and for the values, I'm going to select happy again. And I make sure it says count A. And now I have a frequency distribution for the variable happy. We'll do that one more time for our control variable. Let's take a look at the variable sex. I'll select this next cell, A25, data, pivot table, existing sheet, tell it where I want it, or where the data is, and I tell it where I want it. There we go, and we're going to go to rows, choose sex, and go to values and choose sex, and make sure it says count A, and there we go. So now we know what the distribution of these three variables are separately. The next thing we're going to do is add a second variable. What we want to do is create a crosstabulation. A crosstabulation is a joint frequency distribution. It's essentially a frequency distribution that shows two variables, and it will give you the count of each value for two variables plus the intersection between the two. So watch how we do that. We're going to create another pivot table. It's going to be a little different this time. So I'm in A30, go to data, go to pivot table. I'm going to tell it where the data is. I'm going to tell it it's in an existing sheet where we want to put the pivot table, PT exclamation point A30, and create. Alright, we've got a blank pivot table. So we are going to do a pivot table that shows a cross-tabulation between our independent variable, degree, and our dependent variable, happy. So we go here, and first thing we want is in the rows, we're going to put the dependent variable. It's going to go to happy. And you can see up here I've given you some information, right? So pivot table position, we want the dependent variable in the row. This is the position for creating the cross-tabulation, just so everybody knows. Dependent variable will be in the row, and the independent variable will be in the column. So I'm going to go here, and I'm going to choose row, and I'm going to put my dependent variable, that is degree. And then I'm going to do something that we haven't done yet. I'm going to also put a value in the columns, and that is going to be my independent variable. Oh, no, I messed up. That's okay, we can fix it. If you put the wrong variable, it's actually pretty good that I did that. If you put the wrong variable, you just hit this X button, and that'll get rid of it. So we're going to try this again. We're going to go to the rows, and we want our dependent variable in the rows. We're going to select happy. And then we're going to put a value in the columns, and we want our independent variable degree in the columns. Now we have a very different looking pivot table, right? We have a pivot table that shows happy and the categories of happy over here in the rows, and degree and the categories of degree down the columns. Now we also have to add our values, so we're going to add the value, and the value is going to be happy. So we're going to go here, and we're going to select happy. And now we have a cross-tabulation. This is a joint frequency distribution of the two variables happy and degree. We can see the total for each column will tell you the total of people that have each level of degree, and you'll notice these numbers match over here. And if we look at our rows, we can see each category of happy, and the total will tell us how many people fall into each category, and these numbers match right here. But we also have these numbers in the middle. This is the intersection of two variables. So from this file, there are 1,676 people who say they are happy. There are 377 people who have an associate's degree. But there are 157 people who are happy and have an associate's degree. And from there, you can look for patterns between the categories of the two variables. We're not going to spend too much time on trying to identify patterns, but what we want to do is we just want to be able to create these tables right now so that we can summarize what we can see about these tables. Now, there's one more thing we can do here, and that is to add some percentages, which will make this even more helpful. So we're going to add another value, right? So this one's a lot different from what we've been doing. We have a variable in the rows, a variable in the columns, and we're going to have two sets of values. So I'm going to add another value, and I'm going to add happy again. So let's find happy. Now you'll notice it says summarized by count A. This one also says summarized by count A. So we see duplicate numbers here. Well, we're going to change that to, instead of show as default, we're going to show that as, it'll show as a percentage of the row or a percentage of the column or of the grand total. What I want you to use is the percentage of the column, and that is because we have, the way we have set this up is by putting the independent variable in the column, and we want to percentage the independent variable here. So now you'll see we've added a second column to this table for each category of the dependent variable, and the independent variable degree. And so when we say that there are 157 people who are happy who have an associate's degree, we can also say that 41% of the people that are happy 41% of the people with an associate's degree are happy. So what it does is it gives you percentages down these columns, and it's showing, so this 377 is 100% of the group that we're talking about. We're just talking about people with an associate's degree. And 41% of them are happy. Now we could look over here at the bachelor's degree, and we could say, okay, of the people with a bachelor's degree, 37% of them are happy. Now you'll notice that there's a no answer here, and that seems to be messing us up, right? Because how do you account for the people with no answer? Well, there's a way to do that. over here where it says happy, the second value that we've been working on. Actually, no, that's not where we're going to do it. We're going to actually add a filter. And the filter is right here. So we add a filter. So we're going to add a filter here. And we're going to filter by the same variable that we've been working with. Select happy. And we're going to go to this drop-down list where it says, what do you want to filter by? What do you want to show? Well, I want to show the categories happy, not happy, and very happy, but I'm going to get rid of all the people who didn't answer these questions. Now it has gotten rid of that extra category of no answer. So now the numbers have changed, and we can see that now there's really only 268 people who provided information about having an associate's degree, because it has filtered out all the people who did not answer the question. And it's essentially filtering out people who didn't answer both questions. So they might have had an associate's degree, but they didn't give us information about whether or not they were happy. So we go back here and we see that 157 people were happy who had an associate's degree, and that's 58% of the group. And the reason why those percentages changed is because we don't have the people who gave no answer anymore. You could remove them from these frequency distributions the same way by selecting one of these frequency distributions and going back and adding the filter and filtering out the no answers. So you can see there's a lot of different things you can do with pivot tables. I'm going to show you one more thing. Another trick that you could do instead of starting from scratch and setting up a whole new pivot table is you can actually copy and paste a pivot table and then alter it. So I'm going to copy this pivot table. Actually, I think what we want to do is highlight the whole thing. Copy. I'll go down here and I'm going to paste it. So now I have a copy of this pivot table. I want to add another layer to this pivot table. So this so far is the same, right? We have one variable happy in our rows, another variable degree in our columns. We have two values. We have a count and a percentage. And we have a filter on, filtering out all the people that didn't answer. Really kind of complex. Well, let's add another layer of complexity. If we go back to our little cheat sheet here at the top, it says the control variable. We're going to put this in the top position of the rows. So what I want to do is I want to add another row. And I'm going to add the variable sex. And you'll notice it put sex underneath happy. Well, I don't want it there. I want it in the top position. So I'm just going to click it and drag it up. And once I do that, you'll see that this pivot table got even bigger. And what it has done, it has taken this pivot table that we created and split it into the categories of the third variable. This is essentially a crosstab with three variables. It's a crosstabulation that's broken down by the attributes of the third variable. So we have the same crosstabulation, the independent variable degree across the columns, and the dependent variable happy down the rows. But now we have those broken down by females and males. And that's why I told everybody that you should use sex as the control variable just for this example, so that you can see sex is a good control variable in this sample because there's only two category values, and you can quickly see that, okay, the numbers match, right? The totals match, 268, 268. But what it's done is instead of showing you three values, it's showing you the three values for female and the three values for male. And it gives you a total for female and a total for male. As you can see, these pivot tables are really useful for summarizing large data sets. And you can go wild. You can add more variables to the rows, more variables to the columns. You can add variables to the filter and filter out different groups. You can change the value that it's summarizing. So instead of giving you a count, you can ask it for the average or the maximum, the minimum, the standard deviation. You can get really, really sophisticated. Now, you also have to realize that the more complicated you make your pivot table, the harder it is to read and understand, right? These frequency distributions that we created are really simple and easy to understand. This crosstab is a little more complicated, but once you realize and orient yourself to what's there, you can say, okay, this is really valuable. Same with this one with the third variable. It's a little more complicated, but once you know what's there, you go, oh wow, this is really helpful. But if you add a fourth variable or another filter or another value to summarize, it just gets bigger and bigger and more complicated. That's not always a bad thing. It's actually really helpful if you want to summarize a large data set. And there are lots of other things you can do with pivot tables beyond just creating simple counts in a frequency distribution or joint frequencies with a crosstab. But hopefully this will be a good primer into pivot tables and how they're used and what they're used for.